Hello friend, welcome to the Java puzzle. Today we are going to discuss about Luhn algorithm. Luhn algorithm is also known as the modulus 10 or mod 10 algorithm also, and it is a simple checksum formula used to validate a variety of identification number such as credit card number, IMEI number, Canadian social insurance number, and so on. So today in this video we are going to discuss how we can use this Luhn algorithm for credit card validation. And here in this tutorial we are going to use Java 8 and Stream API for validating our credit card number. So for this, firstly, let's discuss what is the Luhn algorithm. So as I already told you from the starting, it is a check digit system used for many different purposes, including verifying credit card number. Then for this, let's suppose we have a credit card number which is showing here 3379 5135 6110 8795. Now we have to know how this number is valid or not. So first thing, how this Luhn algorithm work. So firstly we have to compute a weighted number sum with the weighted pattern 2 1 2 1 2 1 and etc. Except that if multiplying a digit by 2 would give you a two-digit number, you add those digits together. Then after, add up all of the result. If the sum end in 0, then the credit card number is valid. So let me show you in the example. Here you can see we write down a digit here. Then we have a weight here 2 1 2 1 2 1 2 1 and 2 1 so on. Then we have to multiply this digit to weight. Then 3 multiplied 2 is 6. No issue with that. This 6 is a less than of 9, so we don't have to do anything. Then we multiply 3 with 1, no issue with that. Then if you will see in the third number, there is a 7 and weight is a 2. So when we multiply this 7 multiplied 2, it would be 14. And now this 14 is a greater than 9. So what we have to do, we have to sum up the 14. 1 and 5 unit place, we have to sum that. So 1 plus 4 is 5. So multiply would be the 5 here. Then 9 1 9, then 5 to 10, and 1 plus 0 is 1. So same like we will do our multiplication, and when we will sum up this, so if you will sum up this 6 plus 3 5 9 1 1, so it would become with the 70, and 70 which is a multiple of 10. So we can say this credit card number is a valid number. So let me show you how we will implement this logic using the Java 8 Stream API. So let me move to my code part. So this is my IntelliJ, and before starting any coding, if you like this video, please help me to grow my channel. So please like, share and subscribe and share with your friends. So let me suppose I have this card number and we are going to validate that this card number is a valid credit card number or not. How we can implement this logic. So according to the algorithm, if I will write here the algorithm, first thing is to convert in the array. Then second thing, we have to multiply with the alternate number. So 2 1 2 1 2 1. So wherever the 1, we don't have to multiply that, but in the case of 2, if we have to multiply with the uh, alternate number. Let's suppose if we are going to multiply 2 with the 1, then second digit would be 5, which would be the we have to multiply. Then 9, then 4, then again 9, then again 9, then 4, and then 3. So like that we have to multiply that. So second logic, to multiply by 2 with alternate number from array. Then second thing is if multiple is greater than 9, then sum the digit number. Okay. Then last one is to sum up the multiple and check that final number is multiple of 10 or not. So if it is a multiple of 10, then it is a valid credit card number. Otherwise, it is not a valid credit card number. So for that thing, let we are going to use Java 8 Lambda. So first thing, before moving to the logic part, I'll just show you how I'm going to convert this string to array of integer. So generally what we can do, what process we can follow. So first thing, we can use caret. So using the caret, it would be convert our string into array of character. Then we have to convert that character of array into a list of integer or array of integer. Process is two verbose and time taking, right? So how we can do that? If let's suppose I have a char of, and you can see this one is totally converted. So let me show you. Now you can see. So this concept we are going to use here. So let me comment this, or let me remove that. Okay. So card number dot, here there is a char. Okay, chars. It will convert our string into a int string. So char, and here if I will see for each, and if I will print that, you can see all the number is converted into the character. Okay, so there is a one issue. We have to convert it into a first uh, integers, right? Int string. Now here we have to use map, and you can see it is a convert into the array, right? So first logic is done. Okay, now we have to multiply by 2 with alternate number. Okay, so for that thing, what we can do? So first thing, so remember one thing, if the length of this string or the card number is even, then we have to use 2 1 2 and 2 1. Otherwise, in the case of the odd number, length of odd number, then it would be 1 2 1 2 1 2. So we are going to make this flexible. So I'm just going to implement one logic here. Int a of array is equal to card number dot length, and percent 2 is equal to 0, then it would be 1, then with 2. So before moving ahead, I just want to show you one example. Okay, so let's suppose if I will just going to print one uh, a of 0 is equal to 2. So what would be the output here? Can you guess that what would be the output here? If you guess that the output is 2, then you are in the right path. Otherwise, you have to brush up your Java skills. Okay. Well, let me move. Okay. So output is 2. Fine. Then let me comment that and just move to the our uh, logic. Let me add the bracket. Okay. And here what happened here? So when the first time when a0 is equal to 1, in our case this is the even number, it would be the 1. Okay, initially it would be the 1. So we check here a0 double is equal to 1, then we are going to multiply with the 2. Okay, and we are going to multiply, but before multiply we just update the value of a0, which was the 1, now it is a 2. Okay, and next time when this map will start for the next number, that time a0 would be the 2. Okay, and in that case this one would be the false, and it will be multiplied with the 1. And before multiplying with the 1, we just update the value of a0, so this time it would be the 1. So this will alternatively it will multiply with the 2 1 2 1 pattern. So now this one is look like a clumsy, right? The verbose code is here. I will reduce it. So let me comment that so you can see uh, here what we are going to reduce here. So I'm just going to write again math, and here, so here I can write like that, n arrow and n multiply, because n multiply is already present in both of the return, so we can generalize this, and then uh, we can write that, uh, let me add the bracket here, a of 0 double is equal to 1, then it should be a of 0 to 2, then a of 0 is equal to 1. Uh, and here I can add a of 0 is equal to, and add the bracket here. So what happened here, like when this a0 double is equal to 1, so it would be 2, otherwise it would be 1, and then we will update our a0 here, and then whatever the 2 or 1 is here, it will be multiplied with the n. So we reduce this if else with a single line of code. Now there is a lots of bracket here, so we are going to remove that bracket. Okay, so in that case, I will also comment that, just add the final one here. So map n of n multiply, and here I can write like, add me the bracket here. So just it would be the segregated. So a of 0 is equal to a of 0, and here double is equal to 1, 2, twice 1. So now it's a compact, and you can see it is reduce our line of code here, right? If multiple is greater than 9, then we have to sum the digit number. So I have one more logic here. So if you will see, let's suppose I'm just going to multiply, let me comment here, yeah. So when I'm going to multiply 9 with 2, so it would be 18, right? And when I will sum up this 1 plus 8 is equal to 9, so final value would be the 9. So what logic I'm going to implement, like 9 into 2, which is a multiple, is the 18. So when I will minus with 9, so it will also present me the 9 here. Okay, so this logic I'm just going to implement. So for that thing, what we are going to do, map and here we will check that n is greater than 9. Then what we are going to do, we are going to multiply, sorry, we are going to minus with, not capital, minus with 9, otherwise we can take the n. Okay, so now this is fine. So if I will run that, so we can see the multiple would be there. So if I will see the 1 with 1, then 3 with the 2, then 5 with the 1, then 8 is uh, 8 with the 2, then 8 multiple with the 2 is 16, then 1 plus 6 is a 7. So 7 is here. Then what we will do, then we have to sum up this thing. Okay, so we just use sum. Okay, and now it will return the integer. So let me run inside my system.print. Now I just enter the valid credit card number. So if I will check what is the sum of this credit card number is coming, so if it is a multiple of, yeah, now you can see 17 is here. So now this one is a multiple of 10, so it would be the valid. So now we have to check that also, this fourth number, the final thing. So for that thing we have to check, sorry, this one is a multiple of 10. So now our logic is completed. If I will run here, so this one is a true. If I will make it 2 and then try again, now this one is a false. So our logic is completed. Now our logic is done, our method is done. Logarithm, and let me see. So just print it here and card number. Okay, oh, let me make it a static, or can, okay, just make it a static. I don't have to make a, sorry, I don't have to make any. And now let me check. Fine. So if you think this video is helpful for you, let me know in the comment section. Thank you. Bye bye.